Today we are going to learn about the inverting schemitt trigger. Now if you see, this is your inverting schemitt trigger circuit connection. Now this is the positive feedback that we have applied, and we have kept both R and same, R1 and R2 same, which is equal to 2.2 kilo ohm. This is 2.2 kilo ohm. Now let us calculate what is V positive. This we want to calculate V positive. Now V positive will be nothing but the potential divider, means V naught into R1 by R1 plus R2. Now as we have kept R1 and R1 plus R, all the R, so our value will be around 1 by 2. Now what will be V naught? We have bias with the plus 10 and minus 10, means so our V naught will be plus 10 and minus 10 by 2. So we are going to get plus V set and minus V set is equal to 5. Now if you see, when inverting terminal voltage will be more than non-inverting terminal, then you are going to get a minus V set. How you are going to get a minus V set? Suppose V in is greater than, suppose V plus is here, if V plus is 5 and V in is greater than 5, that is 6, I have calculated. 5 minus 6 into 10 to the power 5, this is open loop gain. It is going to give you minus V set. This output you are going to get a minus V set. Minus V set is nothing but minus 10 volt. Now when V in is lesser than V positive, now suppose V in I have kept 4 and V plus is a 5. Now 5 minus V plus is a 5, and 5 minus 4 into 10 to the power 5, it is going to give you a plus V set. So output will be plus V set. Now when the input is greater than 5, you are going to get a value which is minus V set. We have seen here input greater than 5, you are going to get a minus V set, and when a value lesser than minus 5, when I am going to give the value lesser than 5 volt, you are going to get a plus V set. That we are going to see in the circuit. Now if you look at the circuit, this is the biasing we have done. This is the positive biasing that we are providing with the green wire. The blue wire provides the negative biasing, and this is R1 and R2 we have connected same. It is around 2.2 kilo ohm, and this white wire is giving the input around input at the terminal 2, and from this yellow wire we are taking the output. Now let us zoom to DSO. Now if you see, this is the input that we have provided. This is a 5 volt. We have taken channel 1 and channel 2 on same. Channel 2 also on 5 volt. Now if you see, if the input is going above 5 volt, this one block will count 5 volt. If the input is going above 5 volt, now input is around 5 volt. Now let us increase my input. If I go to around 5.40, then we are going to get a negative V set. Now when the input is going lesser than 5 volt, you are going to get a positive V set. Now we are going to check the plus minus V set point. Now I am going to connect the blue terminal to terminal 3, so that it will give a plus and minus V set. Now if you see, this is going to give you plus and minus V set. Now channel 2, this is blue one is channel 2, the maximum is 4.2. It must be around 5, but because of that practical that we are doing, because of some resistance extra, because of change in resistance, that resistance is not ideal, you are going to get a 4.20 volt. And if I check minimum, if I go to minimum, it is around minus 4.60, means it is plus and minus 5, around plus and minus 5 you are going to get. Now if let me change to maximum. Now this is your maximum. Now if our input is going greater than 4.0, then only we are going to get plus and minus V set as well as the output. Now if I decrease my input, then you are not going to get minus V set. Now if I change my output level also, you are not going to see the output. Unless and until I change my input to greater than around 5 volt, then you are going to get the output. Now this is the output, that this is plus minus V set. Now if you want to see the output, this is your output. Now if you want to see the hysteresis curve, now let me zoom to display. Now if you want to see the transfer characteristics, now let me zoom to go to display first, and then here you will get the format. There you just tap and you will get the XYX format. Now if you see, any voltage which is greater than this one, this is your input this horizontal is your input and this vertical is your output. When any voltage is greater than this voltage, what is that voltage? It is greater than 5, because you see channel 1 is 5 volt, channel 2 is also 5 volt. This one block is around 5 volt. If value greater than 5 volt, you are going to get a negative voltage, and any voltage which is lesser than 5 volt, you are going to get a positive voltage. This is only the inverting operation. It is doing the reverse role. Means greater than 5 volt, it must get a plus Vset, but because of inverting, it is going to give a minus Vset. And what must be the hysteresis area? It must be 10, because we have set the beta, that is R1 by R1 plus R2, as 0.5. 0.5 into 10, it is going to plus Vset 5 and minus Vset minus 5. So this area is 10. How you will calculate this area is 10? This is set on 5 volt. This is your 5 volt, and this is your again minus 5 volt. So the total area it will come minus 10 volt. Now what I am going to do, I am going to change my DC point, means biasing point. I am now 10. Now I am going to change it slowly. Now if I am going to keep it around 12, you see the plus Vset and minus Vset has changed to 12, because this is peak to peak. This around came to around 24, because plus 12 and minus 12. And now see this V input has also changed. Means after V input, when it is greater than 6 volt, then only it is giving minus, because plus Vset area will also set, because plus Vset will be 12 into 0.5, it will be 6. If value greater than 6, you are going to get minus Vset, and value lesser than minus 6, you are going to get a positive Vset. So this is all about the inverting ischemic trigger.